Here it says for the following function, sketch the graph. The function is y equals 1/2 to the power of x minus 3. I try to compare this function with initial. The initial would be y equals 1/2 to the power of x, which is, I have to say, base is between 0 and 1. And anytime we say base is between 0 and 1, my graph is increasing. When I go further and further, x goes larger, my graph would be increased. So is increasing graph, and here the number in front of this initial shows I change my asymptote up or down. Here is negative, so asymptote will become down 3 units. For initial function, the asymptote would be y equals 0. But here the asymptote would be y equals -3. And then it asks find the range. For range, we should know when it start asymptote from -3 and it goes until positive infinity. So I say the range would be the set of all y such that y is larger than -3. As I said, asymptote is y equals -3. I will show all of them on the graph. And the last part asks find the y-intercept. For y-intercept, I put my input 0. So x equals 0. I will get my y-intercept. Then y would be 1/2 to the power of 0 gives me 1. So 1 minus 3, which is -2. Let's use technology to graph this function and show all of this part on the graph. Okay, here first of all I try to use the initial function, which is y equals 1/2 to the power of x. If I graph it, we will see on 0 I will have 1, and the asymptote would be 0 here, and the range is from 0 to positive infinity. And y-intercept is, when I put x equals 0, y-intercept would be 1. Now I will go for the function that I have, y equals 1/2 to the power of x minus 3. Here we will see the asymptote comes down 3 units, so asymptote would be y equals -3, and the y-intercept will come down 3 units, and when I put x equals 0, y-intercept would be -2. And again, the range would be from -3 to positive infinity. So we will see the asymptote would be effect on the range and change my range. The first initial function was from 0 to positive infinity, but here it's from negative 3 to positive infinity.